All right, we're back. Let's go back here to this guy. Sorry. Required fun. Chapter 1. Let's first talk about something you probably all know about. Let's quick review. Energy. What is energy? What's the definition of energy? Yeah. I'm not going to go that technical with it to start with here. It's the capacity to do work, right? Energy. Yeah. Yeah. We're not going there yet. We'll have a good table for that in a while here. Maybe a week. Okay. Power. It's the rate. Okay, of doing that work. So, and you're right, yes, the SI unit. Did you deal with SI units in your, oh good, oh good. Joules, power is a watt. Okay, now there's other units of energy, foot-pounds, BTUs, what else we got? What's the common one? Kilowatt hours. All right. So that power is equivalent to energy over time. So that energy is power times time. Oh, big T or little t, I sometimes. Okay, so. There were students in 102 who were pretty bright, not very many of them, maybe one of them, who got a strong A, but even well in the semester would confuse power and energy. Myself, not being very bright, but I worked around energy for the better part of my career. There's a big parameter we dealt with at the mill. We called it power. We didn't call it energy very much, but we called it energy too. And you read an article in the paper, what do they talk about? Either one. They're interchangeable. In a technical, scientific sense, they're not. Okay? And I find this as a way to illustrate that fact. Okay? Let's say we've got I'm going to say this word problem and then write down the given and find for it. It's going to be a real simple word problem. Okay, and when we get into talking, when I get into reviewing what I want out of these assignments, this is how I want them laid out, but I'll get into that later. But it'll give you an idea why I'm being so anal about how this is being laid out for something this relatively simple. I won't give you the miles per hour and how far to Bozeman problem. That you guys are too advanced for that one. So let's say I've got a 100-watt light bulb that's in my hallway at home. My wife can sometimes, she goes to bed way later than me, leave that thing on all night. Let's say that thing can be on 10 hours. How much does that cost me? Okay, what do I need to know? Let's see. So I want to find the cost of 100-watt bulb. I'm going to write faster and hopefully you can see it on for 10 hours. Well, I need to know how much my electricity costs. Yeah, let's say it's 10. That's about what it is around here, isn't it?
Yeah.
Let's say it's 10 cents per kilowatt hour. We pay for energy. We don't pay for power. Kilowatt hour. And we know we're given it's a 100-watt bulb. Okay. Okay. And we know that's on 10 hours. and I'm already doing something wrong in it. Okay, time. Power used is not really correct. It uses different power than that, but it's close. That's what it's rated for. Okay. Okay. We want to find the cost 100 watt bulb on for an hour. And let's say we're going to find this cost, and here's going to be our answer in dollars. 10 hours per day. So we'll find this thing in dollars per day. This guy cost me. Okay. Well, how much power does that light use when it's turned off? How much does it use when it's turned on? 100 watts, right? How much power does it use when it's turned on for 10 hours? Don't confuse power and energy again. 100 watts. 100 watts. That thing uses 100 watts when it's on. Okay? When it's off, it uses nothing. Nothing in between. Okay? Now, in reality, there's the differences with that, but nothing in between. That's all you know. But if that light bulb is on 10 hours, how much energy does it use? Okay? So we'll go here. Get to the, if I can find it again. Where'd you go? There you are. Move over here to do the problem. Or maybe not. There it is. Where'd you go? So we want to find the energy. Okay? So we've got a 100 watt bulb on 10 hours, right? So what's that equal to? That's 1,000 watt hours. And let's go ahead and I'll cheat a little bit here times how many watts per kilowatt? Oop, there you go. How many watts per kilowatt? And it's in the back of your book. 1,000, yeah. And you'll have the appendix is really valuable, and we'll go there in that regard. Kilowatt, but kilo is always 1,000. Okay, equals 1 kilowatt hour. Okay, so I know that I'm using 1 kilowatt hour per day. I skipped a unit here. Per day, it's 10 hours per day it's on. Okay. What's the cost? Yeah, kilowatt hour per day times the 10 cents per kilowatt hour. See where your units cancel? Here, and we did that up there. It's simply 10 cents a day for that one light. Say I've got 10 of them on. It's going to be $1. I'm not happy. $4 will buy you a beer in some places. $1 will buy you a beer in others. Yeah, so 10 cents a day. So that's a pretty simple problem, but I think it illustrates, and I went there quite a bit last semester periodically to remind us of the difference between energy and power. Okay, simple as that. But they're so interchangeably used, it's pretty easy to get off on that. And as we get into more complex problems, you get into calculating or determining the physics of a wave and or calculating the power of a wave, you can really get twisted around in where you're at. So when I when you do your problems, I always want you to list the find and given before you go anywhere. Now, there might be some other givens. I didn't list the conversion, 1,000 watts per kilowatt. You might want to list those too. You may or may want to not do that. And I want you to always write down the find and show your answer. It can be double underlined. Okay. So it's a pretty simple problem, but this is the way I want you to lay your problems out. Show your calculations, always show your units. Okay, what do we got here? in 100 watts. That's the number, that's the unit. Okay? Hour. That's the 10 hours. That's the number, that's the unit. Always show your units per day to be more applicable. And what's this? That's the dimension of time. And Brad is really big on understanding the difference between units and dimensions. And I've got a table to look at, maybe not today, that'll help straighten that out for you related to energy. Okay? And we'll get into the definition of a joule as dimensions and as units. We'll get into the definition of power as dimension as units. Okay? Going all the way back into force, as these guys were talking about. Moving a force over distance is energy. It's work. You're doing work. Okay? All right. How are we doing here? I'll go here real quick. I spent a bit of time here in 101, but just in case. When I took energy technology, 2012, a long time ago for you guys, for me, just yesterday, I was with a number of fellow compatriots from the pulp mill, many of them, some of whom weren't too educated, good guys, smart guys, but not too educated. And they had a heck of a time with word problems, and I helped them with it. And I, as an engineer at the mill, would sometimes get pretty lazy in how I did them, and I'd go back and try to have to, maybe there was different parameters coming. We didn't have Excel then, so, man, you know, it took a lot of work. Well, be clear in writing your units. They had a heck of a time understanding one thing. Here's a real simple problem. Let's say I'm traveling 60 miles per hour, and I've got to go, I won't do the Bozeman thing to you guys again, 120 miles, poor guys. Whoops, that's an L. How long does it take me? A couple hours, right? I mean, you guys, all the time, you got this much, your red lights on your gas tank. Well, I know that's a gallon. Yeah, how far do I got to go today? Do I wait? Can I wait until tomorrow and the gas price goes down 2 more cents or not? Well, you do that kind of stuff all the time. But what sometimes people aren't thinking about is, and that's a miles per gallon, same as a miles per hour kind of problem. Let's say I want to find how many hours. Now these guys I was with could do this because they did it all the time in their head, but when they got into a more complex problem, I want to find hours. I know I'm given something that's in hours. Let's start there on our problem. Let's start there. However, they struggled with this 60 miles per hour. They had a heck of a time writing it. They could do this pretty good. But they did not know many times you could write it like this. This is what you're trying to find in your numerator, hour. 60 miles per hour. Well, you're there. Take your times your 120 miles. I'll try to read this along. Not too bad. There you go. There's your 2 hours. Okay. So when you get more involved, I won't say complicated, more involved, word problems, be anal about writing down your units at the beginning, okay, and all the way through your calculations. And if you write those units down at the beginning and you look at what you're trying to find, now sometimes the word problem won't ask you what units it needs to be, and you need to figure that out. You write them down. Then go to your givens and find, well, which parameter there is going to start me in the path towards that final thing. This time it's hours, and maybe there's a whole bunch in there before you get to the hours. Okay? Maybe you're all there, but I wanted to go there for a moment. I forgot to do this part. Okay. Let's pause it.